I run a consultancy called LiveWyer here in London, and we use Kubernetes to solve a number of enterprise problems, as well as work with companies who already have Kubernetes to solve their Kubernetes problems.
Okay, yeah, I'm Christoph. I'm working for Fujitsu. Fujitsu is very active in Kubernetes project. We work on OpenStack integration and also to a large part in dashboard. We help our customers to run Kubernetes on OpenStack. And if you want to learn more about it, just check out Kubernetes.io. We just posted a blog post about it.
So I originally wanted to call this talk Kubernetes Dashboard, Past, Present, Future. But Christoph was like, think big. So he decided that we're going to do Kubernetes Dashboard Unleashed. So the structure of the talk will pretty much follow that, where Christoph will talk about where the dashboard project's been before. He'll talk about where the project is now. And then afterwards, I'll pick up and talk about the possibilities around the dashboard project and what we can do. So.
Okay. So this is a situation we had in Kubernetes 1.1. We had basically two UIs. The Kube UI, which was a front end for the Kubernetes API server. And we had the Kube Dash, which was a front end for the Heapster API server. Now, basically, what these two UIs did, they kind of took this server information and kind of dumped it into the browser. And Kubernetes 1.2, we wanted to take a different approach. We wanted to put the user at the center of the application design. We looked at the problems and the use cases and really tried to come up with the best solutions. And also, we wanted to make one general purpose UI that really covers all areas. The two use cases we focused on was first, help beginners. Help them to deploy the first container in Kubernetes. Help them to deploy the first application. And second, we wanted to support operators in monitoring and running application in Kubernetes. And in case of an error, help them to quickly drill down to the root cause. Now, in order to support these use cases, we had to collect information from various sources and combine this information in new ways. And this required a fundamental shift or change in the architecture. So the front ends no longer could talk directly to the API servers. Instead, we needed a backend component that contained this new presentation logic. And because of this architectural change, we could not reuse the existing code. So we had to restart from scratch. And the result, I will make a live demo and show it. If you want to try it out at home, make sure you use the latest versions of Dashboard and also of Heapster. And with latest, I mean it should be no older than 3 days. Okay, let's see. No. Okay. This is a landing page. This is a page when it looks like the first time you open Kubernetes, when the cluster is completely empty. We call this page the zero state page. And from this one, you can very easily deploy a container. That's the first thing I will show. Very easy. You just click on deploy an app, give it a name. You type in the container image. You want to expose the port and also make it available outside the cluster. Create it, and it's running. So what's happening behind the scenes, we not only create the pod, we also create a replication controller, a service, and the load balancer. So that's what you see here, and information, and this represents the replica set. And if you want to exit it over the external endpoint, you can click it and directly go to the running application. One thing important to know, the creation of a load balancer takes time and can be 1 or 2 minutes. And so until it's created, you will see the node port link, and it will eventually switch to the load balancer once it's ready. We added a few actions directly to the cards. So from this one, you can directly change the pod counts and increase the number. Okay. I will delete it now, and we will deploy a full application. I will deploy a guestbook example. Also in this case, if we delete, we not only delete the pod, we also try to clean up everything. So we delete the replication controller and the service that is related to this replication controller. So in order to deploy the guestbook, I select the YAML in this case and click deploy, and already it's running. Also to see the running application, we can again click the link. And before continuing, I would like to create some load on the system. So I was told to use the command line for this purpose. So I keep in sync. Curl helps. Okay, this should be enough. I can close it. So another action we added directly to the cards is going to the logs. So if you want to see the logs, you can open it. And that's very handy for developers. They really like it. The logs view, go from containers to logs, and they can check out what's happened. You also can switch directly from one pod to the next pod in the replica set. And one feature we're very proud of is the night mode. Da! So yeah, we really worked very hard. But so
yes,
whenever you're in the cinema, take out your smartphone and you're ready to run. Yeah.
At 3 a.m. in the morning when all system problems happen.
Yeah, absolutely cool. Okay. So let's drill down. So this is the overview where we try to put all information on this page that are really relevant to your running application. And let's go inside one replica set. Yeah. Unfortunately, so what you see here on left side, again, the information from the replica set. Then you see all the running pods with a chart for a sparkline for the CPU and memory. They will look better as more data points come out. We just would have to wait a little bit longer. Yeah. And second, you also can directly access all events that are relevant to this replica set. And one feature I like really a lot is the way we highlight errors. And this is what I like to show. So the cluster is running on my notebook. It doesn't have a lot of CPU power. So, and the way I create an error is just like creating a few pods, and a few will remain in pending state and cannot be scheduled. So let's increase it to 10.
Go bigger.
Yeah, but I want to continue with the show. So
you said think big.
Generate. Okay. Okay. And let's go to the landing page. This is a page when the operator opens the landing page, the overview page, he directly mark the arrow, and you see now it doesn't have enough resources. And from this page, the operator then can click on the replica set and then dig deeper, drill down to the problems, have a look at the pods, the spark lines, the memory consumption, CPU, and have a look at the events and the logs and so on. Another thing I really like, because we really was effort to implement, is the mobile support. Or at least we can scale down to smaller page sizes. So let me show this. So if I see that, if I scale down, first we take out the left side and make it a tab, the details tab, and if I scale down even more, then we really completely rebuild the full table to make it fit on a very small, narrow screen size. I really like it. So that's about it, I think. Okay. Yeah, it worked. So let's recap. We have, I think we have covered quite a few functionality areas in our first version, and we will improve on it. At Fujitsu, we don't only contribute to Kubernetes, we also have DevOps teams that use Kubernetes. And we did some dogfooding with them, gave them dashboards, and the feedback was very positive. And actually, what I really liked is we deployed them, and they immediately saw one of these errors highlighted on the landing page. And the operator was a bit embarrassed, like, oh. But it proved to be very helpful. So that's a bit, very important. So unfortunately, we did not achieve to get all features in 1.0 version. So one feature that will come very soon are spark lines on the landing page, which will improve the value of this landing page even more. Another feature that will come very soon is rolling updates. So that's a very typical use case. You come to the landing page, you see some problem, and either you want to scale up, scale down, or maybe do a rolling update of your application. So now we'll hand over. We finished this first version, and now we are starting to discuss the roadmap for the next versions.
Okay, I think this is where I am. What's next is a new speaker. So, what's next? Still work to be done on the core elements. We haven't got a full feature set. We need to work on representing daemon sets. There's work to be done on showing jobs. Obviously, jobs the resources, not the contracting jobs that need 5 years Kubernetes experience. And editing more resource types. And to be fair, these are what the team currently feel are your needs. And so really, the answer to this question is that depends on you. Side note, there was internal discussion because originally this slide had a period there, and we all agreed that it was way too passive aggressive, so we had to change it. So yeah, the UI for me is very much a central piece. It's an area in which we can all collaborate around. And so in that sort of context, we want to hear from developers. These developers have just been told they're going to manage application deployments. We want to hear from ops. That's my personal previous experience with working with dashboards. And we also want to hear from management. That's my personal experience working with management as well. But more importantly, we want to hear from everyone. We want to get as much community feedback as possible. So with that in mind, with the UI being such a common component, I wanted to just go through a couple of role play through a couple of scenarios here Friday 3 p.m. And so let's look at this scenario here. So using Kubernetes dashboard to view resources in the context of a developer. So in this context, do I have enough resources to run this application? So imagine now we have this Kubernetes model where development teams are very much self-service driven. They can create their own namespaces, deploy their own applications, but resources are not infinite. And so you may have registered a pool of resources to a development team, and they have to manage that pool. So now they're looking at the resource pool available to them through the UI, and they have to make a decision about either removing some of the resources that are currently being used, or going ahead and putting in a request for additional resources. So that's one scenario. From operations perspective, has there been a change in resource usage for this app since the last release? So in this instance, we understand there are many open source and third-party managed services that work within this space and provide amazing monitoring and metrics and tools. But should there be a product by default? Should there be an entry-level product that is there by default, so when a user goes to access the UI, they can get a complete overview? And if we are going down this route, are we going to implement things such as having markers within that resource, a historic resource grid, based upon maybe deployments that we've made? And so from a management perspective, how much total resource are we using? So this one, I think, kind of speaks for itself. You can imagine management tier getting a bill through, and when we're running with a single cluster, they get their bill from Google Cloud, but then suddenly we've got Kubernetes. And so now they're getting their bill from Google Cloud, from AWS, from Azure, and they want to know why this replica set, certainly not a Bitcoin miner, is costing £10,000 a month to run. So from this point of view, we can give management a complete overview of exactly which deployments or applications are using which resources. So moving on to another scenario. Scenario, using Kubernetes dashboard to edit running apps. From a developer perspective. So again, with this idea of a self-service central platform, this idea of collaboration comes about. And the idea that actually deploying and developing an application is no longer the throwing over the wall method of yesteryear, it's a much more collaborative effort. And so in this space, we've got this idea of where a developer has their own temporary environment, or temporary resources, they can build their application, they can then start making changes to a lot of the areas which typically operations would have control over. But now they can do it in their own controlled area, and they can quickly change settings and get instant feedback. And this sort of instant gratification of using the user interface, I feel, could really shorten that sort of feedback loop between what has been traditionally an operations and a development area. Moving on to operations. So this one is probably quite common. Having seen an issue, I want to make an instant active change. So you may have one of the best, most robust build, test, deployment pipelines, but these are always going to be subject to infrastructure weather conditions. So these things that are outside of your control, So when you've pushed that container out, you realized that it hasn't actually been delivered the way you expected. So in those instances, do we want to have the ability to go in and have control over all of the variables around a running application, so in those very rare events, we can go in and make a quick active change? Management. So this was slightly different one. This one I thought could be a very good use case. The importance of an application has changed, and I need to update the SLA priority label. So the normal motivation for using labels is for generally tying resources to services or tying them to ingress resources. But we can also use application as general labeling for assets. So in this instance, why couldn't we use it for business logic? Say we have a namespace which contains a product. This namespace is obviously our venerable replica set, definitely not a Bitcoin miner. And suddenly there's a request to come through to say that this replica set is now priority 1. So that request come through to management, or they've made the decision themselves. So now they could potentially go in, edit that label, apply that label change. So at a later stage, if there is an issue with that deployment or with that particular Kubernetes resource, the frontline desk who are managing that can see that this is actually a P1 resource. So those were a couple of specific examples, but the Kubernetes dashboard team have got together recently and then just started to come up with some other areas for improvement. Monitoring and logs. What do we log? How do we display those? What do we monitor? How do we display the monitoring information? App creation. Is this something we should be doing inside the application, within the UI itself? Is this something that we leave completely externally for command line for other applications to handle? Active resource editing, that's what we just touched on previously. Single cluster resource view. So in this instance where we have a single cluster and we want an overview dashboard, what is important? What is important to us when we look at this single cluster resource view? And again, it gets more complicated when we have projects like Kubernetes coming on board, where we have a multi-cluster resource view. What's important to us then? And then one of the big questions around this is obviously around ACL and user management. How do we handle these concepts? So, to summarize, we're trying to help beginners. We're trying to provide support to operators. There's still core work to be done. Please go download and try Dashboard. Seriously, please, we need this feedback. We want to hear from all the people. We want to get as much feedback as possible. I honestly feel this is a great opportunity that we have. And having worked with the Kubernetes project for around a year now and understanding the velocity that it's been moving at, if we can just get a fraction of that community support focused on this, I know we're going to have an amazing product. So.
Yeah, again, we really want to hear feedback from you. We don't want to just dump information on the screen. We want to hear about your use cases and really appreciate feedback. So you can help us on Slack and just discuss. You can join us on GitHub, enter issues, or also even commit, yeah, we're very open. On video chat, we plan a community video chat on link.
It's not refreshed.
On 17 March, and we have a pause.
You have not refreshed the page on the latest upload.
Let's see.
Last minute changes have not been applied.
Refresh. Okay.
There we go.
There we are. Very important. So, last one. So we have one community chat, and the last one, we create up a form, and you're welcome to fill up the form. and give us feedback how you run dashboard, what you think about, if you have special features you like in. It would be very helpful for us to prioritize and really get this moving forward. Thank you. So,
thanks very much for listening.
so if you have questions, would welcome to answer. Ah, great.
And if you guys could repeat the question.
Hi. Could you explain the architecture, what kind of technology you use for the front end, for the intermediate back end?
Okay, that's a good question, yeah. Yeah, we're really trying to use all the latest things. Really could package into it, yeah. So the front end is written in JavaScript 6. We cross-compile it with Closure compiler. We use material design, latest versions. The backend is written in Go. So that's about it. And we have a very nice build pipeline. We really compile everything. We lint everything. And we try to squeeze out every byte possible. I really recommend, if you're trying to build your own service on top of Kubernetes, it's a great place to take advantage of and really take it as a template and just remove our stuff and take it as a base for your own project. Because we invest a lot of time in it, and you really could take it as a kick-off start. Huh? Yeah.
Do you need a specific Kubernetes version for that, or what are the general requirements? Can I just go ahead and deploy that on my running cluster, or?
Yeah, basically we want to be independent, not so much tightly coupled on Kubernetes. It works on pretty old clusters. Again, Heapster, if you want to see the Spark lines, you need a very new Heapster, but otherwise it should work.
So the question there was, is there a specific version that of Kubernetes you need to run Kubernetes dashboard?
Yeah, but you just deploy it into your running Kubernetes and it immediately works. There's no configuration or something. Well, I mean, it should be Kubernetes, I don't know, 1.1 or something. Yeah.
1.1.8.
Huh?
1.1.8.
You really? Okay.
How are you thinking about handling scale, where you have potentially hundreds or maybe thousands of replica sets? And
the question, sorry, yeah, the question was how are the Kubernetes dashboard project going to handle scale?
Okay, we did not address performance issues yet. Of course, we won't build up system tests. We started that, and we probably will do the first things like paging and these kind of things. Yeah, that's basically, but if you will put a lot of load in it, thousands of nodes and lots of replication controllers and so on, dashboard will have some problems, I assume, currently.
I'd like to also add that we have Pieter at the front here, who's lead someone stand up, just say hello to everyone, who's heading up development work with the dashboard project. So if there are any specific technical questions that we can't answer on stage here, then please come and see us afterwards, and I'm sure he'll be able to give you some information.
All right, looks like there's no more questions. Thank you.